This conference will now be recorded.
All right, great. So today we're going to do, this is SELDM Class Session 2. We're going to do our first run through the model. So as we talked about before, SELDM's a simple mass balance model. It uses Monte Carlo methods to generate the populations of concentrations and storm flows upstream, concentrations and storm flows at the highway site or from the BMP. And we add our upstream loads to our highway or urban or BMP loads to get the downstream loads. We add the upstream storm flows to the highway or BMP storm flows to get our downstream storm flows, and our downstream concentrations are the loads divided by the storm flows. So all these variables are generated stochastically. SELDM is designed to facilitate scenario tests and sensitivity analyses. So when you get into SELDM, you'll see that there's a project, an analysis, and then constituents. So this 1 to infinity means 1 to many. So each project will hold many analyses, and each analysis can hold many water quality constituents. So what I do is I kind of think of a project as like a drawer in a filing cabinet that holds a bunch of analyses, and each one of those is like a folder in the filing cabinet. And so the project could actually be you're building or improving a bridge, so there's an actual project, or a project could be a little bit conceptual, like it is a bunch of analyses that you want to lump together. Each analysis holds all the hydrologic and water quality variables to do one single run in SELDM. And each constituent is like copper, lead, zinc, and you can have multiple zincs. You can run like a high, medium, and low, or all kinds of stuff. So each analysis can hold more than one constituent. So SELDM has a graphical user interface with a series of forms. So the first 3 forms are analyst, the person doing the job, the project, what's the job about, and as I said, the analysis organizes information together to do one single run. These are the documentation forms. Then we have our site and region forms. We have our highway. We have the GIS grid form, which is just kind of a nerd form to let you know whether your location is within the grid. And then our ecoregion, upstream basin. Our lake basin form is down. And then you get into your 3 hydro. Okay, the first and one of the most important variables that we put in is the latitude and longitude. They're the geographic basin properties, which we can use to specify most of the hydrologic data used in analysis. As we mentioned, we've done a ton of statistics all around the country for you. So when you put in these latitudes and longitudes, you get the statistics that you need. Now, looking at this national map, we can see the black zones are the rain zones, which are pretty huge, and we can see that the colored pastel polygons are the ecoregions. And those are discretized on the level of a USGS quad sheet, so a quarter of a degree. So your latitude and longitude to get you good statistics doesn't have to be all that precise, but if you're documenting, where an actual analysis is occurring, then you might want to get a precise latitude and longitude. The good news is now with like Google Earth or GPS on your phone, it's pretty easy to get a pretty good latitude and longitude. SELDM also uses for the highway site in the upstream basin, just some basic drainage area properties. So this is map view and a sideways view of a stream basin. So for both the highway and the upstream, we need a drainage area, which is this light green area in map view. We need the main channel length. So that's the distance along the main channel, not as the crow flies, but you follow the channel as it wiggles back and forth all the way up to the drainage divide. And then you get this 10-85 slope. So you measure 10 and 85% up the main channel length. You take the elevation at the 10 and 85% points. You subtract the elevations and divide by the distance between these points, gives you your mean basin slope. And then our final variable is the total impervious area, which is the fraction or percent of anthropogenic impervious surfaces. So like roofs, parking lots, etc. So as we go through the graphical user interface, we put in that latitude and longitude and highway site characteristics on the highway form, and the latitude and longitude gets us our ecoregion, and then in the upstream basin form, we enter those basic statistics for, the basin properties for the upstream basin. The next thing we need is representative statistics for the upstream and highway runoff storm flows. So here we have, these are the variables, the upstream storm flow, the highway runoff storm flow, which could be urban runoff, or again, if we're applying a BMP. So our picture on the left is a guy measuring stream flow, and we have a highway runoff monitoring site in Connecticut down there on the right. So we add the two storm flows together, the upstream and the highway, and we get that downstream storm flow. So SELDM generates the precipitation events, pre-storm flows, and runoff coefficients. So with our latitude and longitude, we get storm event statistics. So we apply the storm to the upstream basin and the highway site. We have our pre-storm stream flow statistics, which also are based on location. Our runoff coefficient statistics for the highway site and the upstream basin are based on the impervious area you put in. And again, we generate these flows and we get those downstream flows. So to get those flows, what we do is we, like I mentioned with the hydrology forms, we have the precipitation, the stream flow, and the runoff coefficients. So finally, we need water quality statistics. So we need upstream water quality and highway urban runoff water quality and modified by BMPs. So the highway runoff database can provide data for many constituents for many states. We can see that we have data from across the country, but different data densities in different areas. If your state DOT has water quality data, it would be good to get it and add it to the highway runoff database, because it will calculate the SELDM statistics for you, but it's also will be useful to your fellow DOTs in other states. With the latitude and longitude in SELDM, we've calculated selected water quality statistics by ecoregion. Again, those are the pastel polygons based on data mining from the USGS National Water Information. Only a few samples available in certain places. And as I mentioned, SELDM uses a black box approach to model the net effect of one or more BMPs at a site. So what are we looking at? We're looking at the flow, concentrations, and loads from a source area. And what we care about is the flows, concentrations, and loads that get into the receiving waters. So the BMP form, we enter these statistics to control that transformation from runoff to discharge. So the SELDM forms are designed to be easy to use and have common controls. So there are slight variations from form to form, but as we get into the model, you'll notice that there's a lot of similarities. So once you kind of get the feel of it, it will reinforce itself. So we see on most forms, we'll have this selection combo box. So once you've entered something, it will be available to you in this drop-down box where you can just select it for future use. Then we have our process options. The coming in, the default is to select the current, then you can edit your current, in this case it's analyst, and you can enter new. And then you look at the data entry tabs. The things that are bolded with asterisks are the required things. Other things are maybe good to have, but not necessarily required. And then down on the bottom, we have the database navigation menu. We have the common forms because people, they might need to leave work to pick up the kids or something. There's an exit SELDM button on every form so you can get out and pick up where you were tomorrow. There's an accept updates. When you make a change, these buttons become alive. So because we haven't made a change, we don't need to accept them. If everything's been saved, we can proceed to the next form, or you can always go back to the previous form. So this is the database navigation menu. So once we run SELDM, it sets up a standardized directory. We worked with EPA to kind of make sure things would be accepted by them. So they like the idea of kind of like a timestamp type system so that people couldn't go in and willy-nilly change results to get the answer that they want. So when you run SELDM, it will set up a FHWA-SELDM directory on your root of your hard drive. Or your primary drive, usually it's the C. So within that, when you create a project, it will put all your analyses in a project name folder. And under that, each analysis will have an analysis name folder. And each day you run the analysis, you will get an output for that day. And each time on that day you run that analysis, you will get a run number. So if you run something and you realize you messed it up, and then you run it again, you'll get a second run folder. Or, you could be using the same analysis or just changing variables to see how they, affect, like doing a sensitivity analysis, seeing how they affect the answer. The better way to do that is to copy the analysis and then change the variable within each copy of the analysis. So when SELDM runs, it creates a systematic file naming convention. So for all the files that come out, the prefix will be the analysis name with any weird characters taken out. And then it's the out.txt file is the output documents, the output documentation. The -PE is precipitation events. -PS is pre-storm streamflow. -SF is storm flows. -DF is dilution factors. -HQ is highway runoff quality. -UQ is upstream water quality. -DQ is downstream water quality. -lake is lake analysis. And -annual is annual highway runoff. Now, depending on what you specify, you may or may not get all of these files in your output folder. So if you're not doing a lake analysis, you're not going to see the lake file. If you're only doing highway runoff and you're not looking at downstream, let's say if you're doing a TMDL analysis and you don't see the UQ, with the class exercise. Okay, so the idea of this class exercise is just to do a simple thing so you can see that you don't need, advanced GIS skills to run SELDM. You don't need a lot of fancy stuff. My bad dad joke is that if you can do online shopping, you can run SELDM. So here it is. Our learning objectives were to run through the interface. So don't get too focused on, what numbers we're putting in. The idea is to kind of run through it and get familiar with the interface. We're going to play with the controls. We're going to look at the question mark buttons, which gives you help everywhere. We're just going to enter some numbers, run the model, and take a first look at the output. So you've seen, if you've been to our YouTube page and looked at some videos, you probably recognize Howard Brook, which is a 1.34 square mile basin in Northborough, Mass. It's got I-290 along the southern border of it. That drains right in at the right at the stream. I-290 at Howard Brook is a 6-lane highway with a breakdown lane on each side. You can kind of see the brook here. It's not a bridge, it's kind of like a huge culvert, but from the air, you really can't see it. Here are our basin properties. I will chat these to everybody, but basically our latitude is 42.3353 and our longitude is minus 71.6641. If you're currently prepared to run SELDM and you want to do it in your neighborhood, you could just pick a latitude and longitude that's representative of your area. You won't get the same results I do. You'll get results based on your local precipitation, ecoregion, and stream flow. So here we are. Our area is 6.4 acres for the highway, 1.34 square miles for the Howard Brook. Our channel length is 2,767 feet and 12,000 feet for Howard Brook. Drainage slope is 71 feet per mile for the highway, 150 feet per mile for the upstream basin. And our impervious fraction is 1, which is 100% impervious, and 0.041, which is 4.1% impervious. Now, if you or your kids play video games, you might be familiar with the term cheat code. So in SELDM, the cheat code so that you don't have to do the basin development factor is a -1. So if you put in a -1 for the basin development factor, it will use the imperviousness to adjust the basin lag factor for the highway and upstream site. Basin development factor is not tough to come up with. It's just a little bit more work. The answer is a teeny bit better, but given all the other uncertainties, it's easier just to use the imperviousness. All right, so right now we're going to run through the interface, again, play with the controls, look at the question mark buttons, play with some numbers and run the model, and then take a first look at the output. All right, so now I will bring up the SELDM application. And if you'll bear with me, I'll try and share that. Whoop. Let's see. Applications. Okay, and again, I think if there should, the other thing you can do is up top, it will give you a chance to see what, if you're looking at the people, see who's talking or whatnot. But if you just select see no one, it will give you a little more screen real estate. And again, on the right, there's that zoom in. So hopefully you can zoom in a little bit and see the interface a little bit better. So when you open SELDM, you should get the this opening screen, and we've got version information and explanation, disclaimer. Right now, we're just going to hit proceed. So as I mentioned, when you come in, the first thing to enter is an analyst. Now, with the analyst, that's for an environmental impact statement, EPA, when you do an EIS. As you can see, the current analyst. The only two things that are required, because they have an asterisk and they're bold, are the name and the role. And the analyst role is really just kind of on that environmental impact statement. Are you the primary, secondary, reviewer, examiner, etc.? So I don't need to fill any of this in. In an EIS, they kind of want to know a lot about the people who did the analysis. But again, for this, it doesn't really matter too much. So right now I can accept updates if I've made changes, or I can just click select current to get back to where I was. Let's proceed. Now we're on the project identification. So last time I've already put in a Howard Brook project, but we'll do it again. We'll enter new project. We'll call it S2 for session 2, Howard Brook. And again, if this was, I guess we'll make it I-290. So basically, I'm just clicking in these boxes. So if I had an actual project, The short title, because it appears up here, is usually limited to 250 characters. These longer titles of the different things are usually 250, which I think is the Access short text limit. If it's actually got an ID number, organizations might be the state DOT and federal highway or whoever's involved in the project. Our system variables are mandatory, but they are preset. We're using the predefined GIS grid, the predefined ecoregions, and the predefined rain zones. So if your state wants to make its own GIS grid, its own ecoregions, let's say you want to go to level 4, your own rain zones, you can do that. The only downside of that is once you do that, you kind of have to come up with statistics for those zones. So it's there available for you, but for most cases, I would just stick with what's in there. And then most of these things have this abstract field, which is like an unlimited memo field. So you could put as much information about this project as you want. You could put in, War and Peace in there. I think it's an unlimited data length field. Everything you put in here will end up in your output files. So you may not necessarily want to put in a lot of extraneous information that you don't need. This kind of, as you go through SELDM, you're kind of building a documentary record of your runs. It's good to put in enough to leave breadcrumbs so you come back 6 months later and say, what the heck was I doing? But like I said, you may not want to put in too much, and definitely don't put in derogatory information about your boss. I guess, sorry, that's a bad dad joke. All right, so I'm going to hit accept updates and move on to some of the more interesting forms. Let's see. So now we come to analysis, and we'll do Howard Brook. I'll call this a level 2. So this is the short name. Because I've just defined a new project, there's no analyses available to me. If I'd gone to one of the other projects, I'd already done the analyses within that project would be available. Again, think of your filing cabinet drawer and your folders. So we've just created a new drawer. There's no folders in it yet. So we have our short description, again, 250 characters. Our analysis options are draft, final, supplemental. That is just, EIS information. Master random seed is just kind of a Monte Carlo model dial there, and then the type of analysis. So I guess I should have mentioned thus far is you see these little question mark buttons. When you click on them, it will pop up information about that particular thing on the form. So in this case, it defines what the analysis status are. And you can copy if you highlight it, you hit Control-C, and you can paste it into like Word or another application. So that can be helpful if you are doing an analysis where you have to write a report. Okay, now I'm status. So if I was going to copy an analysis, or if I'm coming back from tomorrow and I need to know, where I was yesterday, at every step along the way now, you can click on information and then analysis status. The things that I've specified will show up as checkboxes. So if I'm going to copy an analysis, I should probably run all the way through it and then copy it and then make the changes I want later than having to re-specify everything. So there's several reasons for using this analysis status information. Okay, so basically we've just set up a basic analysis. We've given it a name. In this case, we won't add a short description, but so we'll hit proceed. And now we come to the highway site. So in this case, it'll be I-290. And you can copy and paste from one to the other, just highlight Control C, Control V. All right, and I guess I should go to the chat and chat the variables to you guys. All right, so my latitude is 42.335. My longitude is 71.664. Now, it's set up the way GIS works, so it's got a negative longitude in the Western Hemisphere. So for the highway site, we're 6.4 acres. Our drainage length is 2,767. Whoop. Our slope is 71. Our impervious fraction is 1. It's 100% impervious because we're going to simulate the shoulders and median as our grassy swale BMP, and then we have our basin development factor -1. Now we have these others. We have lanes, lane width, feet, average daily traffic, pavement material, type of curbing. These are not used in any calculations. If you want to put them in there, again, it will be documented in the output. That may help. You could have 2 highway sites where, let's say, you're adding another 2 lanes, so everything else would be the same, but your area of your highway site would be bigger. So you could, you could call it I-290 before, I-290 expanded, and, to further specify what's going on, you could put your lanes in here. And again, you have this site description box that you can put all kinds of stuff in, as much information as you want, perhaps where you got it, how you got the numbers, etc. So, okay, so I've put in the numbers that we have right now, and so now I just need to accept updates. So it says, we've got this message pops up, it says you've specified a -1, the basin lag equation using the basin lag factor and imperviousness will be used. So that just lets you know you successfully specified the imperviousness basin lag equation. So right now, now we're on a highway site, I can copy current. So let's say I want to do one run with, I-290 as it is today, and one run if I've added 2 lanes. So let's just say we'll copy the current. And when I say that, it will tell me what to do. You have selected copy current. This option will create a new highway site using information from the selected site. The user should complete the input process for the selected highway site before making a copy. Changes that are made as part of the copy will not be saved until the copy button is clicked. Once copy lanes, let's see. So let's go up to 8.5 acres. But everything else remains the same, the length, the mean basin slope. So I've just added extra lanes. So now I say copy site, or I click copy site. Okay. And now see, I have 2 choices. I have I-290, I-290 plus 2 lanes. So we can proceed. Now, this GIS form is, again, if you don't get a red message saying you're outside the grid, then you're fine here. If you enter a latitude and longitude outside the grid, or clearly outside the grid. On the previous form, it might give you a warning, but here, as long as you don't see a big red message or outside the grid, you're good to go. Now we come into our ecoregion. Form is next. So based on our latitude and longitude, we have our ecoregion. I can select an ecoregion. Let's say I'm kind of at the edge of two, but I think, you know, the site that I'm in is, even though my latitude and longitude says I'm over in the neighboring ecoregion, I know that, you know, the conditions at my site are more like the other ecoregions. So I can manually pick that. If I change them, I can always go back to the latitude longitude version. And that will bring me to the northeastern coastal zone. And it reminds me what latitude longitude I put in. So let's go. So let's proceed. Now we have our upstream basin. So we'll have Howard Brook. At I-290. And our hydraulics here, we had 1.34 square miles. We had a drainage length of 12,619. A slope of 150 feet per mile. Impervious fraction is 0.041. And again, we're using the -1 for the basin development factor. And again, on all these, if you get here and you kind of confused about what to put in, if you click on these, you know, some of these definitions aren't profound, but it gives you the basic information of what you need for that. The mean basin slope measured between points which are 10 and 85% of the drainage length. So we'll close this form. And hydrograph recession. Basically, this is the ratio of the falling limb to the rising limb of the hydrograph. We've done national statistics, and then studies in North Carolina and Oregon have come up with their own statistics, but they're not drastically different from the national statistics. So you're probably pretty safe using the accepted values. So, okay, so now I've put in everything I need, and I'll accept the updates. And now I can proceed to the next. Okay, so now we're in our synoptic precipitation statistics. So with our latitude and longitude, we can go right to a level 1 analysis, which was using a region. So I'll choose ecoregion average. It says select a data set, click generate examine statistics, and then click the accept button. So our data set is the Federal Highway 2010, generate examine statistics. It says there's 33 stations. Continue, yes. Then I accept updates. And then here are the statistics of the average of all the rain gauges in that ecoregion. And if I view related sites, they'll pop up here. I can Control C and I can paste them right into a spreadsheet. I guess the downside of sharing this is to go to a level 2 analysis from a level 1. A level 1 analysis, again, is I don't know anything really about this site. I'm doing a bunch of site across the state. So I just want to kind of get numbers that I think are representative. But let's say let's go to a level 2 analysis. So I'll enter a new definition. So a level 2 analysis is where you use selected station. I'll do selected station average. Now, somebody asked in the last session was, you know, we talk about level 3. That's where you put in a user defined. And with the user defined, you can pick something that you existing and modified it. So let's say I want to take the ecoregion number and add 10% on all the statistics. When I pick user defined, I could do stuff like that. But right now we'll do a level 2. So let's generate examine statistics. So with this and other variables, when I click this, what I get is on the bottom of the form, I get a list of all the precipitation stations in the country in order of proximity to my site of interest. And then when I click things down below, they'll appear up above as the selected things. So for this site, Howard Brook, the closest rain gauge is Worcester Regional Airport, then Bellingham, Buffalo Lake, and Barry Falls Dam are the 3. Now, if you look at these, something weird is going on at the Worcester Regional Airport. It gets 65 storms per year, whereas the next 3 get 50, 49, and 51. It gets 44 inches of rain a year, whereas the others get 37, 35, and 33. When I say inches of rain, that's runoff, in runoff generating events, that's greater than 0.1 inches. So if you're looking at a precipitation atlas, the annual total rainfalls for these areas are larger, but this only counts the runoff generating events. But so what we can see is Worcester's a little bit different. So level 1 analysis, I could just pick the ecoregion. Level 2 analysis, I have to know a little bit about Howard Brook. Is it more like Worcester Regional Airport, which is kind of up on a plateau, very high hill, so it gets, elevation effects, or is it like these other 3 nearby stations, which it is. So I will pick the average of each of these. So as I click them, they appear up above. If I click one, I can either say no, or if I say yes and it comes up here, I change my mind. If I just click up above here, I can remove it. So I pick these 3. I can preview the average. So these are the statistics I'll get from using these 3. And then when I hit create new, it will save this. So this just tells me what to do here. So just say yes. And so it gives me the data set, what I've done, and then the date and time. So I'm just going to modify that to the average of 3. And then no WOR, no Worcester. Okay, and now you can see when I come back here, I have 2 choices. I can do the average of ecoregion, or I've defined this. I can use these average of 3. And if I click view related sites, I get the sites and statistics for these 3. And again, if I do Control C and then Control V into a spreadsheet, they show up. All right, now I'll proceed. So now streamflow statistics, you can see, oh wow, it looks almost exactly like the precipitation statistics, except we are not using rain zones. The way I use this form is the same. So we'll kind of go through this quickly. I'm going to generate examine statistics. I picked ecoregion average, generate examine. It says there's 79 stream gauges. I say yes. I accept the updates. And then we have, here's all the statistics that we need. If I click view related sites, all those stream gauges in the ecoregion show up. I can paste them right into Excel. Okay, let's say I want to and then I want to generate examine statistics. And again, this form looks very much like the picking form for precipitation gauges. And so we can see that based on the USGS network, and we were looking for more natural gauges, we had 25 years of record over like a 40-year period. We ended up with 2,700 sites nationwide. There's more like 20,000 sites nationwide. So I've got a 1.34 square mile basin. I probably don't want to use these large 100 square mile basins. So I'll pick the ones that are close to my station, but also on the smaller end of drainage areas. So I'll pick Quinsigamond, which is 25 square miles, Neshoba, which is 12 square miles, and Little River, which is 24 square miles. Now, one of the training videos on the YouTube channel showed how to use StreamStats to click around your site of interest to find, in cooperation with USGS and Federal Highway, we calculated the statistics for the 20,000 gauges nationwide. So if you click around StreamStats, and I can show you that a little bit later today, that you can get statistics, the SELDM statistics you need from StreamStats, whether or not your state has a StreamStats application. The gauges are available nationwide. So as we had with the precipitation form, and so we preview average, and here we go. We have the average for these stations. So these are the statistics. Now I should mention here that SELDM has these other statistics for hydrologic similarity, so that you could kind of compare, is there something going on at one gauge versus another? But it only uses the average, standard deviation, and skew of the logarithms of flow and the proportion of zero flows. So you can, if you're going to do some user-defined sensitivity analysis where you're playing around with flows, you could just use the ecoregion value for all the other statistics. It's not looking at the 7Q10 or the 4B3 or any of those. So you can leave those alone. You just need to focus on those main variables. And again, if you watch the YouTube video on stream flow statistics and SELDM, it will talk a lot more about this. So right now I'm going to create this new, and I'll say yes, just like we did before. So it's Federal Highway 2010, average of 3 small, we'll call it smaller stations, will be our name. And so now we could choose either the ecoregion or the average of 3 smaller stations. Since we're doing a level 2, we'll stay with this. And I'm going to proceed. Okay, then we've come to the runoff coefficient statistics form. So on the basin form, for the highway basin and the upstream basin, we entered our total impervious fraction. So when we come to this form, it already has used the regression equations that we developed that relate your total impervious fraction to your runoff coefficient statistics, and it's done that for you, but by accepting, you kind of confirm it. So for your highway sites, you can use user-defined, so that's where you might do a sensitivity analysis where you vary upon what we've calculated. You can use the SELDM upstream basin, so if you're simulating, like, let's say, an urban area that might also be affecting a stream you're worried about, as well as the highway, you might want to use that upstream basin equation. There's the Schuler's trim NURP, National Urban Runoff. I would say that I put that in because it's commonly used, but I'd say steer clear away from it. It really overestimates runoff coefficients from highly impervious surfaces. So I definitely stay away from that. And then the SELDM highway sites, which is the, when I choose it, it tells you your statistics. The SELDM highway sites are like 72 highway sites nationwide that we had really good flow and precipitation data. So what this does, the upstream basin form, so we're using upstream basin. One thing I should mention is we want to, this should be hard coded, but the correlation to pre-storm flow should be about 0.7. So I'm going to accept these updates. I'm going to use the default values, and I'm going to proceed. So now we get into the water quality form, and the water quality form has a little more information on it. When you come in, you get this general explanation. You can click here, it will give you instructions for this form, and then because some of the water quality is by ecoregion, it will remind you about the ecoregion. So this information is available to you right there. If you look at the training videos on highway runoff on water quality, we could see there's random, there's dependent, and then for the upstream, there's transport curve. So a random variable is when you just have like the average, standard deviation, and skew, and it generates a random record. When you look at dependent, you are simulating one constituent for another. Typically what you do, why you would do this is if you have a lot of data for one constituent, let's say sediment, and only a few samples for polyaromatic hydrocarbons, PAHs, and there's a good relation between pH and sediment, you can get a good idea of, your range of possible PAHs based on your variations in sediment because you have a lot of good sediment data. For upstream, you have the random, and again, you have dependent variables. If you have a lot of good data for one thing, there's a lot of sediment, again, a lot of sediment data nationwide. If you're looking at metals and rivers, there's not as much, and a lot of the data indicates that most of the metals are associated with sediment. So if you can come up with a dependent relation, you can simulate the sediment and simulate the metals as a function of the sediment. And then for upstream water quality, what we find is that a lot of water quality constituents are related to flow. So things like sediment in stream tends to increase with increasing storm flows. Phosphorus can go either way or sometimes both ways. If the phosphorus is from a wastewater treatment plant, you're going to get dilution with increasing flows. If it's from land, land surface runoff, then it's going to increase with flows. So what we see in some rivers for total phosphorus is you'll get an initial dilution with increasing base flow, and then once it kicks over into storm flow and phosphorus is being, washed off the watershed and kicked up from the bottom of the stream, it'll start going up again. So sometimes we see those kind of hockey stick curves. And then again, we mentioned dependent. So right now we're going to pick, let's do total phosphorus in this analysis. So again, it's kind of a common theme. Our available choices are available down below. So we have total phosphorus available down below. We click on that. It tells me what I've clicked. And then for upstream, we're going to use total phosphorus for the ecoregion, which is pre-populated. Yes. And okay, I guess I can demonstrate if we want to define a new constituent, if your constituents aren't here or you don't want to use these Massachusetts values, it's a database application. If you know Access, you can load it kind of from the back end. You can, that's typically what I do. I come up with statistics and load them up in bulk, but you can go in kind of one by one and define new constituents for all these. And so here's highway runoff random. I can pick a constituent, let's say organic carbon, and then I just enter a short name. When you do water quality in Monte Carlo models, you should also always do it in log space, and it's log 10 is easier to think about than means arithmetic. Negative water quality concentrations. But as with other things, we'd enter our numbers here and then click accept updates. For this run, I'm not going to do that. Okay, so we'll go back. So right now I've selected total phosphorus and total phosphorus upstream. Let's define our downstream pairs. So actually, I should have deleted these from the last class, but we can, let's see, we can edit these. So basically, I entered total phosphorus, no BMP. So I just picked the Massachusetts total phosphorus, the upstream transport curve, and this says no BMP, so I did not click BMP here. I can accept updates, close this form. And I can, let's do suspended sediment just to show you how to do it with a clean slate. So we say SSC for suspended sediment concentration. It's mentioned there. So for the highway runoff selection, we'll use the Massachusetts suspended sediment. For the upstream, we'll use the ecoregion and we'll say no BMP. And so I won't check this box. I accept updates and I proceed. And you can see it's defined here for me, but it's not specified. So like as with other forms, things are available down below, but until you click them, they don't become active. So let's edit this one with the BMP. And it's the same form. So you see it's the same total phosphorus from the highway, ecoregion total phosphorus from upstream, but in this case, we're clicking the use BMP form. So when I click this, that means for this downstream pair, it will run the effects of the BMP. So now I click accept updates and proceed. And now I'll do total phosphorus with the BMP. Now I'll proceed. Okay, the default is no BMP in place. If I said on the downstream water quality form that I'm going to use a BMP, that does not take an effect until I actually specify a BMP. So if I don't specify a BMP, the no BMP and BMP outputs will be the same. So let's pick a flow reduction and sediment reduction BMP. And what that does is it gives me, let's see, I'll edit current. That gives me runoff treatment, which is the ratio of outflow to inflow. And it gives me hydrographic extension. Hydrographic extension is when the BMP slows down the flow. And what that does for you is it gets you more dilution in the receiving waters. So the if you're looking at a TMDL, extension doesn't help because you're looking at these annual loads, so the timing of runoff doesn't matter. But if you're worried about water quality exceedances downstream from your outfall, stretching out the highway runoff flow is going to help you in that regard, that you'll get more dilution into a greater amount of flow. And then we have our water quality parameters. Right now, we only have specified suspended sediment. For this quick run today, we're not going to get into the BMP, entering water quality into the BMP interface. We'll do that in an upcoming session. Okay, so I'm just going to select current. I'm just going to use this flow reduction and SSC BMP. So I won't get any water quality treatment out of this run, but I will get flow reduction and hydrographic extension. So let's proceed. So now we come to the stochastic empirical loading and dilution model run cell. And let's see, when we set up the model, rather than having, trying to set it up with parallel metric and English tracks, because in America, you tend to get your precipitation and storm flow in English units rather than metric, but we wanted to give people metric outputs. So you do have a metric option. The significant figures here, most environmental data is available in 3 significant figures in reality. But if you're trying to verify calculations, you might want to go to this double precision, so that all the inputs and outputs, there won't be any rounding factors. If you are doing TMDLs, your loads are probably only really good to 3 significant digits, but if you're trying to add up all the storm flows from a year to get the annual load or the annual flow, because of rounding, once you get up to very high numbers, the 3-digit rounding can lop off a lot of maybe precision that you don't have, but it's less satisfying to see, if you add up the storms and they're off by 1,000 compared to, the sum of storms that is rounded. All right, let's run SELDM really quick.